everybody. Thank you for coming. My name is Jeremy. I am one of the organizers of the Seattle Postgres user group. We have been here for a long time in Seattle, since like 2010. We meet every month, first Thursday of the month, normally. Always talks somehow related to Postgres. We've had a lot of really great speakers in the past. I have a couple quick announcements, and then we'll get started. First of all, bathrooms are going to be, there's a sign on the wall there if you forget, but it's kind of you go out the back, and they're to the right.
No,
are they
directly behind you.
Directly behind us, thank you.
Yes.
So that's where the bathrooms are. Let's see. If you come back next month, typically we have a lending library of books as well that you can just kind of, not just Postgres, but database themed books. It's a pretty cool thing. Didn't bring it this month, but we will have it back next month. Let's see, we're going to run through upcoming events in a moment. Yeah, one more important thing. There was a sign-in sheet and there were name tags. You might have noticed on the sign-in sheet that I didn't ask for like contact information. If you want to know about meetups, the way that you do that is you go to meetup.com, and that's where you sign up for the meetups. Probably most of you found that already, but just want to let you know that's mainly how we communicate. So the sign-up sheets are helpful because that helps us understand how much pizza we need to order, and like the people that pay for it kind of proves that like somebody actually showed up, which is nice. So we do appreciate the sign-in sheets, but go to meetup.com. That's how you will find out about future meetups. Next month, Chris didn't make it. He just texted me and he couldn't make it, but he was going to. I just put up next month's meetup. It looks really cool. It's going to be about a brand new open source extension called, I think it's called PG Lake, if I remember right. It's coming from Snowflake. Snowflake, if you recall, it was Snowflake and it was Crunchy, right? So a company called Crunchy Data, which is a very long time Postgres company. Top tier, really great company, a lot of great people. They know Postgres well. So they were acquired, rolled into Snowflake, and then what do you know, a couple months later, Snowflake has these really cool announcements about a brand new open source Postgres integration with some warehousing stuff. So it looks really cool. He's got a demo. He's going to be talking about that new open source project where it is on GitHub, how you can read it, how you can learn about it. I'm sure he'll talk about how you can pitch in. So that sounds like a fun meetup. That will be the first Thursday of December, which I think is December 2nd. So I'd encourage you to go check out on the meetup site, sign up for that, and come on back. For events, you want to go through future events and whatever other announcements?
Sure. So I just got back from PG Down Under in Australia, speaking there. That was a great conference to go to. Our next conference is Past Data Community Summit. That's held in Seattle. That is both a Microsoft SQL and a Postgres SQL conference. It's running the 17th through the 21st. We will be manning, Jeremy and I and several other volunteers here will be manning the Postgres booth there from the 19th through the 21st. Other Postgres conferences, postgresconf.org, which some of you may not know, I'm on the board of directors on. That is April 21st through 23rd of next year in San Jose. The call for papers is open and is open until January 30th. If you are a speaker, you get a badge. You have an automatic ticket to attend. pgconf.dev. That is May 19th through 21st in Vancouver, BC. That's the developers conference for people who are working on the source code to Postgres. That's a great conference to meet people to deep dive into the underpinnings of Postgres. Its call for papers is open until January 16th, 26. Also at the PG Down Under, I was talking to some of the Redgate people there, the Australian Redgate people, and they gave us several copies of the Introduction to Postgres for Data Professionals. The book, they had them shipped to me. That'll be added to the lending library next month, and we also have a free copy to give away at PAPS.
Is that the one that Ryan and Grant read?
Yes.
Yeah, Ryan Booz and Grant Fitchie, they're great. So they just got a new book out.
Yep.
And we're going to have it.
Yes.
Tomorrow.
Yeah, they sent me 3 copies, one for me personally and one for, and I said, hey, could you give us one for SEAPUG? And so they gave us one for SEAPUG too.
Nicely played. Personal copy.
Yeah. Well, no, the personal copy is what they were giving me first, and then I asked for SEAPUG on top of that.
All right. One more event I'll throw in when you're done.
Okay, I'm done.
There's also, if you like to travel, there's a Chicago event coming up. He mentions call for papers. I'm working on the schedule for spring. Just one thing about this user group is that we're very intentional. Like every sort of block of sessions that we do, we make it a point to have people that aren't like polished professional speakers like this guy is here. Go ahead, you give him this talk a bunch. I'll introduce him in a moment. But like we do, every quarter we've got a couple people, we make it a point. Like I'm always out there like finding people and being like, please come, like I want you to give a talk. If you haven't spoken before, if you haven't done a lot of public speaking, you can talk about a project you did, you can talk about just kind of a hobby thing that you're doing. For this meetup, we try to connect everything into Postgres one way or another, but I'm working on the spring schedule. I'd love to, I can do lightning talks, like I can, last month or the month before, we did like 4 15-minute lightning talks back to back. We just made everything themed on Python. That was a lot of fun. So we can do that kind of thing. So yeah, I just want to, a lot of opportunities here. If you want to try out, just kind of sharing some of your knowledge with some other folks around Seattle. And then the Chicago conference, I'm friends with Teddy, so I want to mention that one. I know like it's pretty far away, but like it's kind of a Midwest-centric conference, but if you want an excuse to travel out there, you could put in to speak at it, and I'm sure she'd love to have a few people from Seattle come out there and just give talks at the, does somebody remember what it's called? Because the name changed. It's like World of Data or Prairie or something. Prairie Postgres, I can't remember. But there's a great brand new conference, just started up recently, now they're going to be running it every year. Okay, I think that's all my announcements. So let me introduce our speaker for the night. So really appreciate you coming out. So this guy, by the way, I gotta say, like I've been watching online and I noticed, like you have in your bio here, so okay, I'm gonna read this. That's what I always do. Bohan's a member of the technical staff at OpenAI. Prior to OpenAI, I remember you co-founded OtterTune, I've known for you a little while now, which was a startup specializing in automatic database tuning services. You didn't write it in here, but it was based on a lot of machine learning stuff, so there's a lot of connection there. And Bohan, you've also been a speaker at various Postgres conferences like PostgresConf 24, Silicon Valley 23. You skipped several. Like I looked at that list and I'm like, I know you've also spoken in Montreal, right? At the little mini conference there.
Oh yeah, it's the same talk.
Yeah.
But we add some new stuff here.
So I've seen you giving this talk all over the place, and I'm like, wait a minute. This is like our hometown guy who lives here in Seattle, and you've never given the talk in Seattle. Like, come on. So I finally got him. So we got him here today. Also, Bohan co-authored with Professor Andy Pavlov from CMU the article, which is very widely circulated, the part of Postgres that we hate the most, which critically examined Postgres' implementation of MVCC. It's a super fun article if you haven't read it. And it is also cited in the Postgres Wikipedia page, so very official. So everybody give a warm welcome to Bohan. Thank you.
Thanks everyone. Thanks for coming, and thanks the Seattle Postgres group for having me here. And I'm Bohan, and today I'll talk about how we scale Postgres to the next level at OpenAI. Before that, I want to acknowledge my my colleagues, Zhang Li, Sicheng, Chaoming, Chonglong, Dimitri, Kai Chi, Stas, Ben, and Venkat, and many more at OpenAI Infra team to make Postgres super scalable and reliable at OpenAI. And we also want to thank you to the Amazon Postgres contributor team for sponsoring pizza today. Don't get me wrong, we're on Azure, but Amazon, we select Amazon just for pizza. Cool, let's get started. So background, I'll talk about like a little bit background, how we use Postgres at OpenAI. And I will talk about like, how we optimize Postgres to scale it to millions of QPS in sharded Postgres. And we will do some case study on the past Postgres outages and OpenAI and what we learned from that. And yeah, and there are some feature requests about like, how think that Postgres can do better. Yeah, this is specific for the, because I was given talk at the Postgres community, so that's actually the special section for them to discuss from our perspective like how Postgres can do better. So a little bit about myself. Yeah, Jeremy already introduced myself, but just a little bit. So I'm working at OpenAI right now. So previously I was a co-founder at OtterTune. It's a startup based on like many years of research from SAMU Davis Group, led by Professor Andy Pavlov. And before that, I worked with Andy Pavlov at SAMU Davis Group on OtterTune research project. Background. So Postgres is the backbone of our most critical system at OpenAI. So if Postgres goes down, many of our key features, including ChatGPT, will become unavailable. There are actually some Postgres instances before have impacted service like ChatGPT in the past. So it's really critical at OpenAI. And scaling Postgres to meet OpenAI scale is not easy. It's a non-trivial task. So we operate on a single primary instance in Azure without sharding for a very long time. Until now, we're still on single Postgres primary. But we miss lots of issues, including REST scalability and also the scalability issues. And we'll discuss how we address them in this talk. So in single primary multiple replica architecture, REST scalability will be a bottleneck. This is because we only have one single primary to serve the right queries. So to address that, we move shardable REST-heavy workloads to other sharded system like Cosmos DB, Azure Cosmos DB. It's basically a distributed key store. So we move most of shardable REST-heavy workloads to the Cosmos DB, and we don't allow adding new tables or workloads in existing Postgres tables. The current tables only allow to serve the current workload. So adding new workload just go to a sharded system like Cosmos DB. And we also did lots of optimization to ensure the current architecture has sufficient runway to support existing heavy workload and future growth. We also work with Microsoft Azure Postgres team on cascading replication to continue increasing the number of read replicas. This is because of in the current architecture, so we cannot just keep adding read replicas because at some point the primary will still become bottleneck because the primary needs to send all the red-hat log to the all read replicas. If you have lots of read replicas, that will be a bottleneck. So we're actually working with our Postgres team to work on some cascading replication. So instead of sending the red-hat log from one single primary to all read replicas, we have some intermediate Postgres instance so that it can allow us to add in more read replicas to scale more on the reads. And Postgres is not ideal for write-heavy workloads, but for OpenAI's read-heavy workload, it can actually scale very well. So why Postgres is not good for write-heavy? So there are some known issues in Postgres MVCC design, which is multi-version concurrency control. So it introduced lots of issues on table and index bloat. And specifically for Postgres MVCC design, when you update a tuple, even you update a single field of the tuple, you need to copy an entire tuple of the row. So it introduced lots of red amplifications and other problems version change from tuple copying, and also it also increased the index maintenance overhead. It also make it very super hard to tune auto vacuum under write-heavy workloads. And it also if you want to learn more about the write-heavy, why Postgres is not good for write-heavy, we have Andy and I wrote an article about that. It's a I heard an echo somehow. It's the part of Postgres we hate the most. Feel free to check it out. Another issue is that it's actually also not easy to scale read replicas because of the reason we mentioned, right? Because for write-heavy workload, it can generate lots of red-hat log to ship, so it can increase the read replica lag. And the problem becomes worse when you have more read replicas, because at that time the network will become a bottleneck. So under write-heavy, you can generate lots of WAL, and you need to send those WAL to lots of the read replicas. So the replica lag will be very unstable at the write-heavy workload. So right now, read-heavy workloads are still served by unsharded Postgres in Azure. but why we still unsharded and how the unsharded Postgres can serve OpenAI scale. That's the two question we will answer in the next few slides. So why Postgres remains unsharded? This is because the shardable write-heavy workloads have already migrated or are migrating to other sharded systems like Cosmos DB. So we already migrate most of shardable write-heavy workloads off the Postgres. There are still some write-heavy workloads existing in the current Postgres, and it's not very easy to shard, but we are still working on migrating those write-heavy workloads to off the Postgres as well. So right now, most of workloads at Postgres are really heavy workloads. And Postgres cannot scale write-heavy workload, but it actually can scale read-heavy workloads very well. And we also limit the workload, the traffic by not allowing new tables in Postgres. So for any new workloads or new tables, just use the Cosmos DB. And I think the main reason we are still not sharding right now is that sharding the current workloads is actually not very easy. It's very difficult because we have hundreds of application endpoints. And migrating off them can take many months or even years to finish. And current workloads are really heavy, and with careful optimizations, the existing architecture can actually have sufficient runway. So that means that sharding is not a near-term priority right now because it takes months or years to shard, and current architecture can serve the really high workload pretty well, and we have sufficient runway. But still, it remains a possibility for the future.
Quick question.
Sure.
For Azure Cosmos DB, are you guys using the Postgres API or something else?
No, just Cosmos.
Cosmos has 4 or 5 different APIs.
We don't use Cosmos. We don't use Postgres API because we have we built our own layer on top of the Cosmos. Yeah.
And how often do you sync them?
How often do you?
Do you sync them, the read and since you are different systems?
We don't sync them. They're actually different data.
Workloads are entirely different.
Yeah, there are different data, different workloads. Right now, we just already migrate most of write-heavy workload from Postgres to Cosmos, and there are still some write-heavy workload are not very easy to shard, but we are in the progress of migrating those write-heavy workload to Cosmos as well. So there are different data, different workload. Yeah.
What is sharding?
What is sharding? Good question. Sharding is so you can think about for example, we have the user ID, right? You can shard. You can for each Postgres instance, if your query only you have the user ID in every query, so you can basically use the different Postgres instance to serve different user ID. So in this case, you can shard the workload by user ID, so in a query, you can route the specific query to a specific instance. So in this case, you can scale the instance a lot, if that makes sense. So in our case, because we have many queries, we cannot guarantee all our query have that sharding case. So that's why it's very difficult for shard in our workload. Yeah, question.
Do the read replicas continue to serve queries if there's a partition with the master?
Do the read replica continue to?
If it gets out of sync with.
Oh yeah, we have. I think Postgres is. I think it's not sync streaming. It's it has some delay, but we can tolerate some delay. It's like a millisecond. If it's less than, most cases less than 1 second, we can. Yeah. It's thank you.
Make it move around, and I'll still hear
Oh
you.
yeah, awesome, thanks. Yeah, in most cases our replica lag is less than 1 second, so our application is fine for us.
Okay.
Yeah, it's not always sync. Yeah, question.
Have you seen any sort of peaks on write-heavy workloads? Do you experience any QPS or DPS?
Peak?
Yeah.
Yes. We. That's a good question. We have actually a peak.
Can you repeat the question too?
Oh yeah. Sorry, yeah. So the question is that have we seen a peak in the rat so that it can cause the issues in our current architecture, right? So yes, we have a peak. Actually, we have more than 10x writes after a very popular feature launch, and it crashes our entire system, including Postgres. So and after that, we actually at that step we actually considering where we want to short a Postgres or we want to still like stay with the current architecture. So we ended up with like just move those heavy workloads to Cosmos DB and carefully optimize the current architecture. So what we found is that we have lots of applications. Actually, it just have like some like unnecessary writes to the Postgres. So we just optimize a lot in our application and reduce the rest a lot. Question?
Is all your infrastructure in Azure, or are you allowed to put it in other clouds?
Oh, we are on Azure, and we, yeah, it's because we have partnership with Azure, and and in future I don't know, but right now we're on Azure.
Okay.
Yeah.
Is it more of like keeping like a data for keeping like a backup in the Azure, or are you guys actually using for user queries real time for like that, like the Cosmos? I mean, like the Cosmos DB you're using is for like customer queries, or is it for like the data that will back up at some place because you need to back up at some place?
Oh, it's not backup. It's for customer query.
Oh.
Yeah, previously we used Postgres for some customer query, and right now we migrate those heavy to Cosmos DB, and they go to Cosmos DB directly. But these are not backup.
Oh.
Yeah. Cool. Question?
Why did you choose Cosmos DB for migration?
Oh yeah, because we need some sharded system, like a distributed system like KV Store, and Cosmos is the probably only one option, I don't know, on Azure. And we already used Cosmos DB before for other workloads, so it's actually a natural choice for us to continue to use Cosmos for other workloads as well. Yeah. Okay, cool. Cool, those are good questions. So we first want to reduce load on primary since we only have one single primary. First of all, we want to mitigate write spikes in primary. That's the question that we had actually a very spike writes, so it caused lots of issues on current architecture. So we migrate write heavy workloads which are shardable from Postgres to the Cosmos DB, and we also reduce the number of writes at the application level because after that step, we found also like unnecessary or duplicated writes to the Postgres, so it can be reduced in the application level. And we also use lazy writes where possible to smooth out the write spikes. So that means that for example, when you sign up an account, there are some writes we don't need to do immediately, and it basically just have a lazy write so that to smooth out those write spikes. Another issue is related to the backfilling field. So if you want to backfill the field in the existing tables, you have to set a really low rate limit when backfilling. Sometimes it takes us a week to backfill a field, but it is what it is at Postgres. And for the reads, besides the write queries, we also want to offload the read queries because this is a single primary. We want to just make it reduce the load as much as possible so that it can have enough capacity for our future workloads. So we also offload those read queries from primary to read replicas where possible to reduce primary load. Some reads cannot be moved to the writes to read replicas because of transactions. Because of some reads is actually in the middle of the transaction which has writes as well, so they need to be a single transaction. In this case, we just we make sure those queries are sufficient enough and efficient enough in the primary, so there's no slow queries for those reads. Query optimization. So we avoid long-running idle queries by setting lots of times out. There are the different knobs related to timeout. Long-running queries can block auto vacuum and can cause lots of issues and also consume lots of resource. We set the idle intersection session timeout, which means that if the query is idle in a transaction, if it exists this timeout, it will get killed automatically by Postgres. We also set the statement timeout because sometimes we find the query is not in transaction but still in idle. So we also set statement timeout. We also set the client side timeout so that it will also get killed at the client side as well. Another thing is that we want to avoid OLTP query anti-patterns. This is because we actually observe multi-ways joins in Postgres queries. The most expensive one actually joining 12 tables. And we have the set before just because we have such spikes in such expensive queries, and it slows down both the primary and the real replicas. So we want to avoid that. So usually these queries are not written by human. It's generated by ORM. And when you're developing your application using ORM, it can easily lead to such like 12-way table join queries. So you need to when you're using ORM, you need to use it carefully, and you need to carefully monitor what is the general cycle of the ORM. So if you really need joins, you should not do it in the Postgres side. You should do it in the application side. You should fetch the different data from tables and just join in the application side instead of join in the Postgres side. Yeah. So that's the query optimization. Another thing is the single point of failure. So we want to avoid single point of failure because we only have one single primary. If it's down, if the primary has some issues, we don't want it to affect a lot on the application. So if the read replica has some issues, it's really fine to the application because it can route queries to other read replicas. But for writes, we only have one primary. So we want to mitigate the single point of failure as much as possible. So we only have one single writer. So if it goes down, no writes can be performed. What we found is that most critical applications are actually, and the requests are actually read only. In this case, we can continue to operate those requests because it's read only. If the parameter is down, it can still read from read replicas, which means that if the primary fails, it will not cause the set 0. Because it can continue to serve those critical requests, which we only need reads. So usually it's a set 1 or set 2, it's not set 0. We also categorize requests by priorities. We have high priority requests, which have a far greater impact on users, and low priority requests have the lower impact. So we dedicate replicas for high priority to prevent them from being impacted by the low priority request. One example is that, for example, in the previous slide, we talked about very expensive queries. If it's a query in a low priority request, and if there is a spike in such query, it won't affect the high priority request because high priority requests go to a different dedicated instance, which is different from the low priority request. So that's how we mitigate those noisy neighbor issues. We also categorize the request by the application as well, so that one application won't affect another. So that's another level of the categorize and priority. Rate limit. So start from a single expense query can bring down an entire instance. So we have the step before, as mentioned, we have spike on the 12-way joins, and the volume was typically very low, so we don't find any issues in the beginning, but somehow there are sudden spikes because of, for example, you have released a new feature or you have a new deployment, we have a sudden spike of such queries. It brings down the entire instance. That's why it's critical to set read limit at different level. So we set read limit on the application level to reduce the load during peak traffic. we also set rate limit on the connection because we also faced lots of issue on the connection pool previously, because it used up all the connections. So that's why we need to set rate limit on new connection as well. We also set rate limit on specific queries. So in this case, we actually implement something that you can rate limit a specific query digest or block the specific queries. So in this case, if we find there is a very expensive queries that is still down in entire instance, we can on the application side we can actually we add in a proxy layer, so we can actually block that specific expensive query so that it won't affect other system and the service. Sure.
Could you say that again? So you have like a filter in place between the
Oh yeah, so we on top of Postgres instance we have a Postgres proxy. We use PgBouncer, and we also have used ORM on top of Postgres proxy. So we implement something inside ORM actually, so that you can in the ORM you can actually block and give it a query digest ID. It can actually block that specific queries. Yeah. Yeah. Question.
When you're calculating the query digest, do you consider query parameters as well? So
No, it's we don't consider parameter values. It's the normalized queries. Yeah. Yeah. Question.
Which ORM do you use?
Oh, we use. That's a good question. That's a good question. We use some Python ORM.
We can get it later.
Yeah, we can get it there. We use fast API and some, but we are not using Django, so we are using some ORM. Yeah, I can check it out later.
So for the rate limiter, is it based on each query, how much it's taking, and like overall the usage of the device or like the infrastructure it's running? Or is it based on like, okay, if I hit number of queries irrespective of small or bigger ones, I'll just create a new connection? Like how does it work?
Oh, so for rate limit, we set at a different level. We have rate limit on both the query level. So for example, if query is the volume is super high, we can set the rate limit on the query level. We also set rate limit on the application level as well. So for example, one endpoint, one request cannot exceed certain threshold. We also have rate limit on connection level, so you cannot create like thousand connection in a second, something like that. Yeah, so we set the rate limit on different levels. Yeah. Question.
a lot of the backend code in Python, or is it also C#?
Oh, it's Python. Most of stack are in Python.
Okay.
What is the parameter for high priority and low priority requests? How
What?
do you decide which is
Oh, well, how do we decide high priority and low priority? It's mostly decided by the business requests, because those are requests from the application, right? It's more like if, for example, if this request we cannot solve this request, what happened to the application? It's more like decided on the business side and application side. Yes.
I was also curious about the categorization, and I'm curious kind of how you, like kind of what layer you're doing it, and how you track it. Like, are you putting stuff in comments inside the SQL statements so that you can look at the database layer and you know like where the SQL statement is coming from? Is it just at the ORM layer that you're doing everything?
It's more on the endpoint API layer. So we have lots of hundreds of like application endpoint APIs. We just categorize those APIs between like high priority and low priority.
Do you have like, are you like if you look like at the activity in the database and you just had like a list of like here's 50 queries that are running right now, like are you able to trace those back, or do you have
Oh yeah.
the application layer and go down?
Yes. So we have some tracing on the query level, so to know we know which which part of code generate this query. So you can basically track that. Okay, so that this part of code generates queries. So this part of code is which API.
And then is that based? That's got to be comments then in SQL text, right?
Oh yeah, we just add a comment. yeah, we have the trace, and we just add the trace in the comment.
Are you using like trace IDs, like the kind of industry standard trace IDs?
We have both.
Okay.
Yeah. Question?
Yeah. So you mentioned that it's dangerous to use ORMs. You have to be careful. Can you touch on like what are the ORM specific things that make it?
Oh yeah. So yeah, the question is that can you talk about more about how we use ORM and some specific thing about ORM? So I think one main thing about ORM is that, for example, if you're using Django, and you have lots of the reference the tables, and so basically you can define models on different class on table, and most of the time you fetch the, for example, different fields from different models, and then actually it generates a join queries in a Postgres, because they need to get those different fields from different tables, so they need to join those tables together. That's actually super expensive, but in the application, when you're developing the application, you just very it's very easy to just write some code to get those fields at once, but actually generate very, very expensive queries in a Postgres.
So you're saying it's not obvious that when you're writing the application code that you're writing these.
Yeah, there are some best practice you need to follow. I think there are some materials online to tell you what's the best practice of using ORM, but it's definitely, it's definitely not very common to generate very bad queries. One simple example is that I know, like for example, if you want to know whether something exists or not, most of the time people just use .count greater than 1. It actually count an entire table, right? But you actually just need to know whether the row exists or not. That's one example of using ORM. Yeah.
So a couple slides ago, you talked about how because of I think partly that it's better for you guys to join in the application than in the database. And I'm curious what factors you have in your environment that makes that true. Because in our environment, that would be a terrible idea. Because there would just be so much data coming out of the databases that it would overwhelm them.
Yes. So the question is that we are saying that, for example, for the 12-way join, way table join, you should now do it in Postgres. You should do it in the application. But the problem is that will be also a terrible idea to do an application because you need to join lots of tables, right? That's, yeah, that's a yeah, that's a good question. So in our side, we actually don't, because most of query are OLTP kind of query, right? If you really need some expensive multi-way join queries, you might not want to use Postgres for that. You might want to use some warehouse or something like that. But for our use case, most of our queries are TP level queries, TP level queries. So each query just stack some, return some very limited number of rows. So you can, for example, if you get rows from different tables, and each filter, so we only get very limited number of rows from each table. So you can easily add them together in the application.
So you're not getting much back from every given table?
No. We don't fetch breakdown query and one query get like millions of rows. We don't have that in the application. Yeah. Yeah, question?
Do you write raw SQL query or just writing the SQL query by ORM?
We are using ORM most of cases. Yeah, in most cases. Okay,
is there any specific extension you use for query digest?
No.
Okay.
No.
So it's just application level.
Yes. Question? Lazy writes, yeah. For example, one example is that when you sign up a user account, and for example, there are lots of features you don't use, right? For example, you don't use their API, other features. So that for those, when you sign up a new user account and you don't use for example, you don't use API feature. And for the API, if you use new API feature, you need to write some new record to the database. But if you don't use that, we don't write that when you're creating an account, if that makes sense. So, So it will, yeah. So when we write that, so it will only write records when you use the API feature, so or some other features. Yeah. So how the idea is that when you example is that when you sign up a user account, and also use feature you don't use, and we don't need to write records for those use cases, and we only need to write to a table when you actually use those features. Yeah.
So am I understanding correctly that your Postgres system is primarily a feature flag system?
It's not just feature flag, but it actually definitely don't store the chat data. It's more like metadata.
Mm-hmm.
Yeah. Because for chat data, it's definitely read heavy. We cannot serve that in Postgres. Yeah, it's more about metadata. Question.
So I guess the really obvious question is, why did you guys choose to have just a single primary and not try to partition at one point?
That's a question. Why do we choose single primary at the beginning? Yeah, actually, I don't have a good answer for that because there's like that 3 or 4 years ago, I think they just use Postgres and they don't expect we'll have the ChatGPT, the full feature ChatGPT, and then we adopt ChatGPT, and then we have see the issue in Postgres and just increase the instance size until we get the largest instance size, and then we do other like more optimization on the replication, and here is what then just get to here just get to like what we hear today, and surprisingly and. The single primary actually serve very well in our use case. Yeah, I really surprised on that part. Yeah, it's more like a historical reason. And if you ask me why, if you do a startup, do you want to share the Postgres at the beginning? Probably not. Yeah, because if you don't have product market fit, you don't want to share over engineering your databases. Yeah, if I answer the question, if I know we'll have ChatGPT, I will share the application in the beginning. But if I don't know, I will just start with a single Postgres. I think that's what the most company does right now. And surprisingly, if you just use single primary, and it can actually take you to very far, like OpenAI. Right? We are still on single primary right now. Yeah, question.
Did you have more joins in your queries at the beginning and gradually kind of move them out as you scaled up?
I think most of joins expensive joins, we move it out. And actually, most of joins, we can break it down in the application layer. Because as I said, it's more like OLTP workload, so it's mostly it's just it just needs to some the sensitivity is very low. It just needs some like small number of rows from each table.
So that was a strategy at the onset. You would do it within the application layer.
Yeah.
Okay.
Yeah. Any questions? Yeah.
Couple of slides back, I saw you mentioning lazy writes.
Yeah.
So there is a case. It's a batch-based updates what we do with the latest update. So how are we maintaining the history if I want to backtrack of what I have done? How is the
So the question is how do we maintain the lazy writes?
So which means that I'll get only the latest update.
Yeah.
But what if I want to backtrack what happened in the history? Because it's different from OLAP and OLTP, right? So how that part of lazy write is impactful?
I think we don't track the. Yeah, I think we should be more clear about the lazy writes. I think here it means that when we optimize the application, I think previously we just have all the writes at once. But what we found is that sometimes you don't need those writes until the users use some features. And then we just trigger those writes until user use some features instead of have all the writes in the beginning, if that makes sense.
Okay.
Yeah. Cool. connection pooling. We use PgBouncer as a Postgres proxy because we previously also met lots of issues on running out of connections. So we use PgBouncer as a connection pool. It enables connection reuse, and we also find it's actually significantly reduce the connection latency. So if you do not use PgBouncer, it takes like 15 milliseconds to create a new connection. With PgBouncer, it can reuse the connection. It only takes 5 milliseconds. It also reduces the number of connections, which is very important for us right now because on the primary and all the instance right now, we have 5K connection limit. I think that's a hard limit. Maybe you can increase to 10K, but that's we have the connection limit on the instance. So it's really critical to keep the number of connections low. And if the replica, that's actually not true. Yeah, another thing I find is that you should configure it properly at PgBouncer. For example, you also want to set some like idle timeout on the PgBouncer there as well. And there are, I think, at least 10 knobs related to the timeout, so you should configure it properly. Yeah, question?
Do I see that right, that you have 5,000 connections going to your primary?
Yes, that's a 5K. We have 5K connection limit on the primary.
That's the limit, but how many do you actually have in practice?
Probably half of them. I don't know. We definitely not use all of them, but probably 3K, something like that.
Okay.
Yeah.
I have a quick question about
Sure.
that slide too. I saw Kubernetes services on there for routing your connections to PgBouncer. So you're using Kubernetes to manage your PgBouncer, it sounds like. I assume you're not using Kubernetes to manage like the read replicas, but I wanted to just kind of check on that.
Oh yeah. So we don't use Kubernetes for read replicas. We use other Postgres, and we have some deployment. Kubernetes deployment, and it has the PgBouncer pod for the deployment, and each deployment actually goes to one replica.
Is that like that Kubernetes cluster? Is that like a mixed workload cluster where you have the PgBouncers mixed in with a whole bunch of other workloads as well? And like, are you able to co-locate the PgBouncers right next to like the applications that are calling the PgBouncers? I'm just curious what you're able to do on the Kubernetes side. I'm sure that will apply to a lot of people.
Yeah. So I think we can co-locate PgBouncers to read replicas, and so for the routing to different PgBouncer, we actually used Kubernetes service. For the Kubernetes, it actually route queries to different deployment, and that's how we distribute the queries between different read replicas. Sorry, can you repeat your question again? About?
Is that the same Kubernetes cluster that also has your like application workloads, the things that are connected to PgBouncer? Are they running the same Kubernetes?
So the question is that do we run the application and PgBouncer at the same Kubernetes cluster? I think the answer is yes, but I think I need to double check. But I think we run it in the same cluster, so that Kubernetes cluster. And we actually have lots of different Kubernetes clusters, and each cluster has its own deployment. And yeah, that's a good question. Yeah, we can really co-locate the application and the PgBouncer. And also we can also connect on different regions as well.
So are you running PgBouncers like in all your Kubernetes clusters, or do you have like one Kubernetes cluster for the PgBouncers?
Oh, that's a good question. I think it's all clusters, and we can actually scale down or scale up the number of PgBouncer for each cluster. Yeah. Cool. So replicas, we have dozens of replicas across multiple regions. Right now, we have almost 50 replicas in the cluster, and we continue adding replicas to handle growing read traffic. And we maintain dedicated replicas in every geo region to minimize the latency. But we cannot scale replicas to a large number because the primary will become bottleneck. So if you keep adding replicas, so the primary need to send the red hat log to all replicas, so we cannot keep adding the replicas. That's why we're exploring cascading replication. So instead of every replica pulling wall directly from the primary will stream the wall to a set of intermediate replicas, and those intermediate replicas can then send the wall to the downstream replicas. They can scale out more replicas without overwhelming the source, the primary. But the trade-off is that it makes more difficult, make the cluster topology more complex. So it's more makes more difficult for failover. So we are actually working with our Postgres team on testing it right now. It's not in production yet. Yep.
So that's a really complicated way to go.
Yeah.
If you're mostly a read-heavy system and you don't have many writes, why not just do something simple like wall archive replication instead of stream replication?
We already have streaming.
So why do streaming? Why not just have everything read as a wall archive?
So the question is why we are using streaming instead of some wall archive.
Because then you can have like some object store, multiply those reads everywhere.
Oh yeah. So I see. So you are saying we have wall archive to some object store and then okay.
I mean, it's slower.
Yeah, it's slower. Yeah.
But if you're mostly read, would it be anyway?
Yeah. That's a good question. So I think it may be related to the replica lag. It may increase the replica lag. That might be one reason. Yeah, I think that might be the main reason. It may increase the replica lag. For the cascading replication, I think most of work on the other side. We just start working with them on testing stuff. Yeah. Question?
Yeah, just kind of clarify. So earlier you mentioned that you're not doing any new, you're migrating all write workloads off of Postgres into Cosmos, and so how does that reconcile with this slide where you're talking about replication from your primary Postgres instance?
Oh yeah. So the question here is that we already migrated most of the writes of the Postgres. Why do we still need a cascading replication? Yeah, so the problem for current single primary architecture is that even if you have few writes, it needs to send the log to all the replicas. So if you have 100 replicas, the network might be the bottleneck. And also, it also takes the resource to replay and send those logs to different replicas. So that's why it will finally it will overload the primary. It's not because we have lots of writes. It's because even we have few writes, but it needs to send all the replicas. If you keep adding replicas, it will become bottleneck finally. That's why in the cascading replication, it only sends the wall to some set of replicas instead of all replicas, and those set of intermediate replicas send the wall to other diff replicas.
And how many layers do you have in cascade?
Oh, imagine it's just one layer of intermediate. Yeah, but it's still in the testing stage.
That's pretty interesting.
Yeah. Question.
Just one question. Can the intermediate replicas become a primary replica if one of the primary replica is down?
Yeah, that's a good question. That's really to fill over. I think right now we are still working on that because that's the hard part in the cascading replication. Yeah. Schema. So we only allow some lightweight schema changes. If you want to have a new table or introduce new workload, just go to a sharded system like Cosmos, and we don't allow use Postgres to new workloads anymore. We allow adding and removing columns in tables, but with the 5-second timeout. Any changes that require a table rewrite are not allowed. So if you, for example, add the column with for example, if you add the timestamp column and timestamp column default value is the current is dynamic value like the current timestamp, they will actually rewrite the entire table. So we definitely want to avoid that when adding a column. So we have the strict timeout on that. We also allow user to add and job indexes concurrently. What we found is that schema changes sometimes can be blocked by some consistent queries. So we usually find that when we apply some schema changes, is failed because it's blocked because some other queries are block the schema changes. So if some long-running queries, like if the query like greater than 1 second, longer than 1 second, and the consistent present on the target table, we find the migration may fail. So what we do is that we run these queries from stack star from pstack activity, and we find the target table and find the interval if it's larger than 1 second. If we keep seeing some queries appear, and it means that those queries that keep reading the table, which blocks the schema change. So we usually fix those queries either in the application side or move those queries to replicas so that it won't block the schema change in the primary. So results. So we successfully scale our Postgres to millions of QPS, powers OpenAI's critical service and products like ChatGPT. And we add dozens of replicas with no increase in replication lag. Usually it's within 1 second for the replication lag. We maintain low latency across geo distribution replicas. So we have different regions. We have replicas at different regions. And we also have sufficient capacity headroom to sustain future growth. We only have one SEAP0 instance involving Postgres in the past 12 months, which is a very popular feature launch I mentioned previously. That's only one SEAP0 in the past 12 months. And I want to huge thanks to our Postgres team for their support along this journey. Okay, case study. Yeah, I'll talk about some case study and issues we faced at OpenAI. So one common issue is cache misses. So usually it's something wrong in the Redis layer, and Redis cache misses increase a lot, and we have more load in Postgres. And since Postgres have more load, the requests become stalled or become timeout. And the caching pool also saturated. And we then have more requests due to retries because those previous requests are not served. And it's actually the virtuous cycle. So you have more load in Postgres, and the request becomes slow and more retries. And then you have more load in Postgres. It's eventually slow down the system a lot. So actually one issue we face that is because of it set the timeout to a very short interval in the application, and that's caused the issue because we have so many retries in the application. So to solve this, we set the rate limit on the Postgres and proxy layer so that it might not overload the Postgres instance. We also rate limit on the app layer, application layer, so that it won't generate too many retries and increase load in Postgres. And we also drop some requests. We also drop requests when we find the instance is overloaded. Yeah. So, but the Yeah, but the fundamental thing is that you want to make sure your Redis is good. It's not misses. It's not cause to catch misses. Yeah, question.
Talk more about drop-in requests when overloaded. How do you do that automatically?
Oh yeah, so I think we have some in the app devel. I think we do it in the app devel. So when we have some like readme on app devel application, if we have too many requests, we just stop trigger those requests anymore. Something like that.
So on the app level, there's some like database pooler, and if it backs up, you just start joining things. Yes. We have some in app devel. Yes, I think in the app devel we have some tracking about the. We have some tracking about the number of requests per minute or per second. If we find there are so many requests, we just drop some of them or just don't request anymore. Yeah, question.
So the dropping request is separate from like, because before we talked about high priority, low priority.
Yeah. I think we have that for all the. That's a good question. Actually, I'm not pretty sure about that because that's not from database side. That's more from another team on the application and infra team. I think they did something on the readme on the app side. I think they do the readme on most of the critical API, and to make sure it won't have those requests for a single endpoint API. Yeah. But I'm sorry, I'm not sure about that. Quite sure about that because that's not on Postgres layer. Yeah, cool. Another thing is expensive queries. So we face the issue that Postgres has some very expensive multi-way join queries, and we have sudden increase in the volume of those queries. Like for example, you have new feature deployed, or you have lots of retries. And Postgres primary CPU usage becomes super high. It's like more than 95%. And the primary query becomes super slow and they impact our critical system service. And most so we optimize that at different layer. The first thing is that we set the readme and we also allow user to block specific queries. So we have the readme on the application layer and also the query layer. So that, for example, you have sudden increase in some those queries, we can actually block those specific queries. And we avoid using the primary for the read-only request to prevent a single point of failure. So if you have, for example, if your requests are read-only, it should go to the read replicas if possible, so that if the primary fail, those requests are still not affected. Another thing is that you should definitely avoid those expensive queries, like 12-way join queries. You should definitely optimize those queries to avoid that. So another pattern is that we have huge spike in the writes, and we find high CPUs in primary, and also the replica lags also increase a lot. It's more than 10 minutes, and the query becomes very slow, and it impacts database service. And after relimiting write queries, the primary usage returns normal, but actually, but the replica continue to increase for some reason. So the huge spikes is mostly caused by the, for example, this year we had a very popular feature launch, and it caused a very huge, 10x spikes writes. So we optimize the application to reduce writes. Because, for example, as discussed before, we find some unnecessary writes in the application layer. And we also have some like lazy writes, so that you can smooth out the writes. And for the primary, because usually the writes cause issues in primary, so we just move read queries out of primary if possible, so that the primary is not overloaded. And we also remove some unused indexes to reduce read amplification, because if you have lots of indexes, it will make the scenario worse. Because when you have lots of writes, and for the writes, you also need to update indexes. So if you have lots of indexes, it's also increase the read amplification. And it makes things worse under the write-heavy workload, under the write specs. And that's the issue, is that we actually found some issue in the network. In the errors network, so there are some like knob is not tuning correctly in the error side. So we just tune some to make sure those network settings are tuned correctly to increase the network bandwidth. Yes, this is the example of how writes can impact the why is Postgres not great for write heavy. So if you have huge spikes and you have lots of writes because of the replication, and you have a single primary, you need to send those write head out to all the replica, and the network then will become a bottleneck. Yeah, question.
Going back to the previous slide, what's the general recommendation you guys give for retry strategy?
Oh, what's the general recommendation for the retry time? I'm not too sure about that, because I know one issue is caused previously is we set retry retry time out too low. Retry time too low, so that I keep retrying. Yeah, I don't. I think it really depends on our application, and yeah, I don't have the specific number of value for you for the retry.
I was just asking about the general. Is it like an exponential backoff?
Oh yeah, external backoff. Yes, we are using external backoff. Yes. Cool. So where Postgres can do better. So what we found is that we lack of query some metrics for specific for query latency. So we have the PgStat statement. It only provides the average latency per query digest, but we cannot get query percentile at P95, P99. So we hope that it can give us some more information like histogram or percentile latency on the Postgres layer. So we have those numbers on the application layer, but we also want to have those numbers on the Postgres layer as well. Yeah, so that's a query latency and indexes. So when we drop unused indexes, we won't drop unused index because it can reduce the read amplification. But we prefer to disable indexes temporarily and monitor performance before dropping them permanently. So currently, Postgres does not support disabling indexes. So you need to drop the index and to recreate it manually if you need edit it back. So if the index is so large, it takes long time to edit it back. Yeah, I think there are some hacks that might make this work, but we don't want to risk that because in production, because that's very hacky. Yeah, question.
Can you just mark it as invalid and be done, and then it's be used?
Yeah, that's a good question. I did some research and I found something online that you can do some very hacky on the in a Postgres to make it invalid. But first of all, first thing we don't want risk. Second thing is I'm not sure we have right permission to do that. We're not sure whether we have super user permission. Yeah, to do that because that's
But Ben, you're talking about just directly editing the system catalog, right? Like
No, like you can like alter an index and say it's invalid.
with like the SQL command?
I thought that. Yeah. If you had that
Can it be something like tombstone, like where it's like just mark it like it's disabled for now, and then the query will optimize accordingly, considering that?
Yeah, I think you can do something hacking in a catalog or something like, it would be great to have like command lines to like disable this index, so we can use that instead of do something hacky in production. Yeah. Long-running active query. So that's another thing we find is that we actually found some queries are active, but it's like more than 2 hours. It's very long. It's active. And the wait event is client read, means that the query is waiting for a request from the client. And the query star equal to state change means that the query has been in the client read state in the entire time. So it means that it doesn't mean the query takes very long time to run this execute this query. It means that this query just waits there for the request from the client. And the state is active, so it cannot be killed by idle transaction session timeout. So we are not sure what happened here.
we have this problem. Tell you what happened.
Oh, yeah, sure, yeah.
So if the client's just being really slow at reading data, we do this a lot by doing copy, like to standard out, to avoid using cursors. And the client just takes the speed time reading data sometimes, and like maybe it's swapping or something.
I see.
And so we wrote a daemon that just kills things like that.
So how do you kill things?
It connects as a super user or some kind of privilege role.
Okay.
And looks for sessions that match a filter.
Okay.
And then filters.
I kill those things. Okay. Yeah. Yeah. That's yeah. We just okay. Okay. So those things cannot be killed by those timeouts. But you are saying we can just do something manually to kill those queries.
Yeah, because I mean literally it's waiting for the client to read data.
Yeah. I see.
I'll add one thing to that too. I think you can do PG terminate backend is what he's talking about, which isn't like any kind of a backend. But these are fun. Like another kind of random thing that I've seen before, but this wasn't in Postgres, this was in PgBouncer, was where as best we think that some kind of a network device or a firewall just like dropped some packets while it was waiting for them to come back, and it just like sat there indefinitely, just waiting for a packet that was never going to come. Keep Alives may have helped with that situation. Like maybe they would have gotten some intermediate device to like send back a reset packet, but like weird stuff happens sometimes, and like we've seen things too that could be a Postgres bug. It could also be like something weird like what he's saying, or like a network thing. Who knows?
But do we have the connection timeout?
But it was, in our case, it was idle. Or not idle, it was active. Like it was in the middle of a network call, like waiting for the bytes to come back, so it wasn't idle.
Okay. So we find some queries, but we don't find, it does not cause any issues in our side. It's just like quite annoying when we find the sort by the query agency, we find those non-queries data, and we just want to kill that automatically. But so far we don't find any issues even if we have those non-queries. Well, it would be great if the Postgres can have some knobs that kill them automatically. Is it possible for Postgres to?
Is it something that you see a lot, or just something you see like?
We always see that, but the number of those long queries probably is not a lot.
You're doing your joins in your application, so that's your problem.
Maybe.
What you could possibly do would be like just try to, if it's happening a lot, like if you're able to catch it, maybe you just have, it claims to be in a network call. So you can go in with there's utilities like SS will grab socket statistics. You can go at the operating system layer and just check the status of your network connections, and maybe try to pull a little bit more data to see what's going on. I don't know.
So far it does not cause any issues. It's just quite annoying when you see those non-running queries and don't know what happened.
Does Postgres have anything like can we monitor the status of like how much the query has been executed, like what stage it is in, like using the logs or anything like?
What do you mean?
Like I mean, like let's say the query is running for a very long time, and then how do we know like at what stage is it? Like is it in some stage still running? It's not like somewhere it's got stuck and then we are just like kind of clueless of what's happening there.
Yeah, there is some stuff. Like I feel like with a question like this, there's always more you could do, right?
Yeah.
But it's not bad. Like, yeah,
Okay.
it's not bad. I don't want to let
Yeah.
him go.
Cool. The last part is the automatic knob tuning. And Postgres default knob notoriously very bad. It's I think we should maybe have better default knobs, either based on heuristic or some adaptive knob tuning, like based on workload, like auto vacuum. So I think we have some industry example here. For example, we always find the cloud provider like AWS or Azure, their default knobs are much better than Postgres default knobs. And there are some features also added in the Google AutoIDB, like adaptive auto vacuum tuning. And another thing is about connection pooling, because we run into many connection related issues before to run on top of connections, or there are too many add-on connections. Correctly configuring connection pooler like PgBouncer. I think it's not very simple. As I said, PgBouncer has more than 10 knobs related to timeout. If you search timeout for their knobs, you can find 10 related knobs about that. So just don't easy to set it correctly. Overall, I think a better default configuration or built-in auto tuning will be super helpful here. Okay, so yes. At OpenAI, we've proven that Postgres can scale to support messy, really heavy workloads. Right now, even with single primary, so it can scale very well for really heavy. And if you're a developer or building a startup, I think just start with Postgres and for really heavy workloads. Because I did a startup before, so my lesson is that I just don't over engineering too early. Just don't over engineering. So one single primary Postgres can take you very far. Thank you.
So are you relatively happy with what you're doing with Postgres now, or?
Yes, we are very happy with Postgres right now, and we are also very happy with working with Azure.
So you don't still hate Postgres, huh?
Like
your blog
I
post
love
said?
Postgres.
Okay.
A little bit of Postgres, yeah.
Kind of a follow-up, what are the pros? Like, is it cheaper than the alternatives, or is it just a lot of people know it, or what are the rationale to kind of...
What's the pros? I think there are several things. The first thing is definitely the community, the developer community.
Okay.
It might be right now default choice for all developers. And another thing is the extension, because Postgres can extend Postgres to a different system. For example, the TypeScale DB, or you can create extensions on top of Postgres. So it's also make the community better, because you have lots of different extensions on Postgres and in this ecosystem. And also it's proven it's proven at lots of different places, and it just can scale very well for really heavy. Question?
Have you explored containerizing the read replicas to be that or is it the containers are only used for PgBouncer?
So the question is do we container a Postgres instance or just for PgBouncer? I think we just use container for the proxy. PG proxy, and yeah, for the Postgres instance is manage the error Postgres. Yeah.
Are there limitations on doing it in Kubernetes, or you haven't explored?
We just don't. Yeah, it's just good to have error to support us. So you want to do it, continue on do it by yourself. It definitely doesn't work. Yeah. And more of our happy is very happy with working with error. We have like hundreds of people support us, and yeah, it's much better than just we have 1,000 people doing it ourselves. Yeah, we actually have some like on-type Postgres at OpenAI, but yeah, I just feel very painful for maintaining and operate on that. Yeah.
So you have one right primary and a whole lot of streaming replicas.
Yes.
How do you deal with the failover of the right primary? You just bring it back as fast as you can and not try to rejigger the web?
Oh yeah, for the failover, I think we have on either we have standby for writer. I think, but if you want to have that different region failover, I think, for example, if you want to failover to a specific replica, I think you still want you can still do that, but it's not automatically. It's not done automatically. You need to do it manually.
So you need to reconnect all the speed replicas after failover?
Sorry.
So you have a single right node.
Yeah.
And then a failover for the right node, and then all the intermediary.
Oh yeah. So you can actually promote those specific replicas in error.
Okay.
Yeah. So you don't need to do it there. So I think they have a standby for the writer. That's probably the easiest way. Like you can also promote specific replica manually.
Sorry, and I guess I'm not familiar with Azure. Does Azure handle all of that for
Yes.
us?
Yes.
Okay.
Yes.
So you mentioned for write workloads, the two main things that Postgres struggles with is the MPCC and the bandwidth that gets generated with while streaming. And so I'm wondering, how does Cosmos or the other database options used for write workloads, how do they handle that better?
Oh yeah. So for distributed system, like KV store, you basically you can shard writes. You do not need to go to single writes. So in KV store, you can the writes you can sharding your writes application. And for other systems like MySQL, actually they have less wrap application compared to Postgres. For example, when you update or insert or update a row, Postgres usually generate more like write head log, more data compared to other systems like Oracle or MySQL. It's mainly due to the MVC design.
And like there are like a lot of sharding options already there for Postgres.
Yeah, right? Yeah. The main point is that it's not system challenge. It's more like the application side. It's very hard to because we have hundreds of endpoints. It's not easy to shard those endpoints, right? Have a single sharding case. It's just not easy to do that.
I have another question.
Yeah.
All right, so, and I'm also trying to keep the camera pointed at you. Okay, so it seems like read scale real easy. You can spin up more read replicas. You've got all these PgBouncers. That works really nice. And one of the things you've talked about all night is how like the writer, that one primary instance is kind of your biggest risk factor. So the name of the game here is like protect that writer at all costs. Now, I'm also imagining, like, I don't really know numbers. If I just like made some numbers up, I'm sure it's not like 5 people at OpenAI. There's probably like hundreds of developers, maybe dozens, maybe hundreds of teams. Like how in the world with so many different teams, so many different developers, like anybody could do anything. Like how do you stop somebody? I'm curious just like how you manage that. How do you protect the primary from all these different teams doing all this development stuff? Do you have automated PRs? Like do you have something that prevents, like, is it that they can't connect to do you have an approval process in place? How do you protect the primary from like a process perspective?
You're saying
use AI.
So you're saying how do we protect?
Yeah, like in practice, just how do you stop somebody from creating a PR that like writes a bad query against the writer, right?
So we
like,
cannot. Yeah, that's why we have SAP before. Right?
That's why.
That's why I said before, we don't stop everyone from OpenAI to create
Right, but like,
PR.
so do you have like automation? Like, if you figured out ways to like auto scan PRs, is it just like an education thing? Did you just teach everybody like don't write queries?
So the question is, how do we stop developers to have PR to generate lots of RAS, from Postgres and generate those back queries? So you definitely have a staging environment, so you can test it before deploying to the entire production tester.
Okay.
And I think that you can do some phasing deploying. For example, you can deploy to a 2% of instance or 10% of instance, and then gradually increase and gradually roll to the entire instance. There are some like it's more like a better testing and better observability, and potentially using AI.
So you aren't actually like stopping somebody from writing a write query. It sounds like it's still a little bit more reactive like, gradual rollouts, good observability. You kind of learn what to watch, but you're not trying to slow everybody down. You still want people to be able to develop, and you haven't like prohibited someone from writing a new query that adds data to a table.
So for any, we mostly do it proactively, and for most changes related to the Postgres, need our approval from our team, from Postgres team, on our API team to make sure their PR is not doing something crazy, and.
Do they just have to add you like to their PR, or do you have actual mechanisms on your repos?
We have. You have to get approval from one of our team member. You can add that in GitHub. So it requires approval from a specific team, something like that.
But I imagine you're not reviewing every single change of every PR at the company. So like somehow you just flag the PRs.
If you relate to some files or some. There has some mechanism to detect whether we should require a review or not. And there are some testing. You need better testing, and also that when rollout, don't just do lots of testing before rollout, and also gradually rollout to like instead of rollout to entire instance a cluster, just gradually roll it out. Another thing is that we can use AI to detect that. We can try to use codecs to do that. Actually, right now, every PR at OpenAI has some review from codecs. It's hard to say that it's it's useful or not, but just say something, and I think most of the time it is very useful. And you definitely cannot stop preventing 100%. That's why you need some mechanism like if you have staff, how do you recover quickly? For example, one mechanism we add is that we allow users to limit specific queries, so that if some query goes to production, we can fix it quickly. I think just need
really cool.
Need efforts from lots of different perspective and from different teams to make it very reliable and stable.
So the query level rate limiting, that's not a PgBouncer feature. It sounds like you have some layer in between your app and your database. That sounds like a cool layer, whoever built that. So that layer has an ability to,
exactly.
You see one problem query and you can just like drop the hash in there and it'll just block that one query.
And also better observability, right? If the Postgres is overloaded, you need to know which specific query caused the issue, and you need to know which code, which application code generate that query. It's just we do lots of things around that. Better observability and better testing, and also when there is a set, how to recover quickly. We have I think we have entire teams. Different team that work on different part, but we have entire org to make sure that our chat piece is reliable and stable. But it's not easy, so we are still seeing some stuff. It's much better than like previous years, but we still see some stuff these days.
So currently you
Oh, that's a good question. So I think we have some like timeout. If the cache is idle for a long time, it just kill that. I think probably is, most of them are actively used, but there's still some issues that we have also idle connection as well.
How many? I'm just curious how large the hardware that is has thousands of
We have lots of clusters. So for the service, we have like lots of clusters, and each service each cluster can generate this query. Sorry, the question is like.
Sorry, is the thousands of connections, are they on the server side of these jobs or the client side of these jobs?
Thousands of connections. So we have 5K connection limit on the Postgres side, instance side. And then we have PgBouncer connection. So we also have limit on that side as well. If it's too many caching on a PgBouncer, it also causes issues. Does this answer your question? Sorry.
Is there anything of what you mentioned would be published as open source, or maybe what the Microsoft the Azure team is learning? Are they potentially going to roll that out as something more?
Yeah. So for example, the cascading replication, they will roll it out.
Okay.
So they are currently working with us. They are saying we are probably one of the biggest skills at Azure. And I think they are saying that no one uses Postgres like that. so that is good. First customer required cascading replication, but they will definitely roll it out and also beneficial to other customers as well.
Like you guys are using the same Azure managed Postgres offering that anybody can use.
Yes, exactly, yeah. Good question.
Yeah, so would you say that you're using one single primary instance for rights or Postgres? Is that like the architecture for a specific service, or do all of them rely on one primary?
Oh.
For all like different.
So all the. So I cannot say that. So I would say that applications use Postgres, needs Postgres use that single primary, but some service applications don't use Postgres. I cannot say which service use Postgres and which service do not use Postgres, but you get the idea. Yeah.
This may be more on the services. I'm curious, like, it happens to the primary, which I've seen in the US. Do you ever run into issues with local contractors where they want data doesn't
Yeah. I think we definitely have this requirement, but probably not for the Postgres data. But we have some. For example, we don't use Postgres to store chat, right? So the chat query, chat data, we don't use Postgres. But some countries that need residence for the chat data. So we need to do some data residency for that part, but it's not in Postgres. Yeah. Question.
Do you ever foresee like any circumstances where you might move away from having one primary, or do you think that's good enough for?
So you are saying where we will have sharding in future, or?
Probably.
Yeah. So the. So I think. So I think why do we have one single primary? It's more like maybe a historical reason, because we just start from a single primary and we just don't shard before ChatGPT launch, and after ChatGPT we just keep adding increasing instance size, and right now we are still on a single primary, and where we want to sharding on nodes, I think it's probably be the long-term plan, but not in the near-term priority, because right now single primary can still serve us for a very long time. And as I said, we are still continue to migrate some traffic, especially write-heavy traffic to the off the Postgres. So if you want shard, you just don't, you cannot do it like just shard all the traffic or workload at once. So that's why we also need right now migrate some write-heavy workloads off the Postgres and do it gradually. So back to your answer, I think remains a possibility in future that we may want to shard the Postgres or just use the more distributed system, but not the near-term priority. Yeah. Good question.
Even though I'm a big fan of Postgres, I know that Oracle has much stronger capacity for writing. Did you guys ever think about maybe using Oracle for primary and Postgres for replication? Or another question, why did you not use Oracle and use Postgres?
So why we don't use Oracle and we use Postgres? I don't know, because when I joined OpenAI, Postgres is just there. And I think it had to some historical reason, and we are. I think we also partner with Azure. I don't know. I think it's more on the business side, because can we use Oracle? I think we can definitely use Oracle to support our workload. It's not a technical issue. It's just I think it's more on the when you choose a database, is something some part related to technical, but some part is not related to technical part.
So. Do you still have beefier machine instances to move up to, or are you already up to the
I think primary is the largest one, or the second largest one, and for all the replica, it's either largest one or second largest one. But I was saying they will keep adding new instances.
I was going to say that, yeah. Azure is going to come out with big, that's the thing, all the cloud providers keep coming up with bigger and bigger servers. So.
Oh yeah, so I think Azure has some automatic failover if the primary is down, and you need to roll back to to the backup automatically. So sorry, not backup, the standby. So you have primary, you have standby. So if the primary is down, it will automatically roll fail over to the standby. I think you need to, if the standby is also down, I think you need to manually promote some replica as a primary. It may take some time, but I think it may cause some downtime, but I'm not sure how much downtime it is. Your question. You have lots of questions.
So this might be the answer just for you as well. But one thing that we do, because we just on bare Postgres, is that when you have multiple stream replicas, if they're in asynchronous streaming mode, then you can certainly get into a place where some are ahead of others, and then that can become a problem during failover. Is that something you have to worry about, or are you all synchronous replication? Or
we have, I think for Azure it's not sync streaming, it's async streaming.
Async or synchronous?
It's async.
So then, do you have to care about some might be ahead of others in case of failover?
Oh, yeah, that's a good question.
It's something we've seen.
I would
I think that's handled in the Postgres in the Azure side.
Yeah, I think Azure's got to deal with
think
that.
Azure got it.
I mean, like they're providing this as a service, right?
That's why we use Azure. That's nice service. We just
You click a button, you get a replica. Like they need to make sure it works.
They have the. Yeah, we haven't tried that, but I suspect it can. It's not easy. I think it's suspect it can cause some downtime, but we haven't tried that. So in most cases, I think the standby is sufficient for us.
I mean, you just PG rewind though, don't you? Like, isn't that how?
Now, we're running.
Right.
You didn't use to
But I think like the cloud providers just have to automate that.
Yeah, they should.
Yeah.
Maybe they do. I mean, they should do cascade replication too, but it sounds like that's yet to come.
I don't know. I haven't tracked with it. But.
Cool. Any questions? Cool. Thanks. Thank you, everyone.
Come back next month.
Thank you. You want him to speak again? Oh, you mean the audience?
The audience.
Thank you.
Sorry.
Thank you. Bohan.
Nice to meet you.
Thank you. I gave it multiple times at different places.
Yeah, you seemed very confident.